A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
For centuries, we thought the ocean was silent. But what if we were wrong? What if, hidden beneath the waves, an ancient, intelligent conversation has been unfolding this entire time? Whales have been speaking, and now, for the first time, we're beginning to understand them.
We said hi, 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 hi. Next time you want to say, how are you? What's up? Any good fish? Whatever.
With the power of artificial intelligence, scientists are decoding their haunting clicks and pulses, and what they're uncovering isn't just groundbreaking, it could upend everything we thought we knew about language, intelligence, and life on this planet.
Are whales talking to each other?
Definitely.
This isn't just a breakthrough, it's the start of a dialogue, one that began millions of years ago. Beneath the waves, a secret has been echoing for millennia. An intricate code of clicks, rhythms, and pulses. It is not random, it is not noise, instead it is communication. And now, with AI as our translator, we're beginning to unlock it. Each decoded pattern brings us closer to a language not our own yet. Cracking the code. How AI is unraveling the hidden language of whales and beyond. In 2020, a group of scientists, linguists, and technologists quietly launched one of the most ambitious projects in animal research history. It was called Project SETI, which meant the Cetacean Translation Initiative, and their mission was far from simple. It wasn't just about identifying the sounds sperm whales make or how often they make them. It was about figuring out what those sounds actually mean. To understand what the whales were truly saying to one another, they needed more than curiosity or good intentions. What they needed was artificial intelligence, which is why SETI brought together an unusual team of experts ranging from marine biologists to AI researchers, computer scientists, linguists, and even cryptographers. This was a unique project because these fields rarely work together side by side. Together they raised over $33 million in funding, including backing from the TED Audacious project, which only invests in bold ideas that have the potential to shape the future. Clearly, SETI wasn't driven by curiosity alone. It was about creating a real connection. What if, for the first time in history, we could decode the language of another species? A language that has been evolving in the depths of the ocean for millions of years. To make it possible, they had to start by listening. So, off the coast of Dominica in the Caribbean, SETI built a state-of-the-art listening station, and across a 20 by 20 kilometer stretch of ocean, they installed a network of underwater microphones known as hydrophones, like a massive digital net laid across the seafloor. They also tagged whales with acoustic sensors, turning the area into a kind of open ocean recording studio. The goal was to monitor wild sperm whale clans around the clock, capturing not just isolated sounds, but full conversations, complete with context, timing, tone, and response. Soon, they were collecting more audio than any human team could ever hope to listen to. We are talking millions of whale vocalizations, each one made up of clicks known as coders. These coders weren't just random noises, but sperm whales' means of communicating with each other. Kind of like how humans use words and phrases. Some coders are short and sharp, while others are long and rhythmic. Some are repeated across different groups, as the whales even seem to have dialects. But how do you make sense of all that? This is where AI came in. The SETI team began feeding their massive collection of whale recordings into deep learning models. These models were advanced systems designed to find patterns in large amounts of data. In one pilot study, a collaborator at MIT trained an AI to predict the next click in a whale conversation, and while this might sound like a small step, the results were surprising. The AI was accurate 99% of the time, showing that the clicks weren't random. They followed a clear structure and rhythm, but most importantly, it suggested a real meaning. This was massive progress, but next was the detective work. Researchers started visualizing the sequences, turning audio recordings into graphs that looked like sheet music, and that was when they noticed something even stranger. They began noticing subtle variations in timing, such as tiny extra clicks and shifts so slight that human ears had never picked them up before. These weren't just technical details, they were linguistic clues. A small change in the rhythm of a click could alter the meaning of a message, much like how a change in tone can completely shift the mood of a sentence. Think of it like this. If a whale says click, 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 and another responds click, click, and that pattern repeats across dozens of conversations, you start to wonder, are they saying yes or are they saying no? Are they saying come closer or go away? All these are questions unanswered as we are still early in the process, but every new pattern is like uncovering another piece of a puzzle that has been sitting unsolved for centuries, right beneath the waves. It is important to note that these aren't isolated whales either. Sperm whales live in complex social groups, often referred to as clans. Each clan has its own set of coders, like a unique cultural fingerprint. Some even pass down certain coders over generations, and this kind of behavior hints at more than just basic survival communication. It points toward culture, tradition, even social learning. This is not just fascinating, it is revolutionary. What's even more exciting is that SETI isn't the only group diving into this kind of work. Across the globe, other teams are doing something very similar, but with different animals. Google, for example, launched a project called Dolphin Gemma, and their goal is to comb through over 40 years of dolphin recordings, using neural networks to detect repeated sound patterns essentially, finding words hidden in dolphin whistles. Again, it's the same strategy with massive datasets, pattern recognition, and deep learning. But it doesn't stop there. AI is currently being used to analyze penguin calls in Antarctica, echolocation from bats, and even the complex songs of birds. In all these projects, one thing is becoming increasingly clear. We have entered a new era of animal research, an AI revolution, not just in labs or code bases, but in forests, oceans, and skies. The field of bioacoustics that was once a quiet, niche corner of biology has now been turned on its head, and what used to take decades of careful listening and note-taking can now be accelerated with smart algorithms that learn faster than any human ever could. But it's not just about speed, it's about opening doors we didn't know were there. Because here's the bigger picture. If we can understand the languages of other species, even just a little, we may begin to see the world through their eyes or ears, and this can change everything. It would change how we view intelligence, culture, even consciousness itself, and force us to rethink our place in the natural world. SETI's work is still unfolding, and there is a long road ahead. They haven't translated full whale conversations yet, and they are not at the point of chatting with dolphins about the weather, but they are closer than we've ever been. And that closeness is no longer just science fiction, it's real, and it is happening right now. What makes all of this so thrilling isn't just the technology, it's the possibility. The idea that buried in thousands of hours of clicks and whistles and calls, there might be something familiar, something meaningful, something we recognize not because it sounds human, but because it's intelligent in its own way. What if these patterns weren't just communication, but music with meaning? As AI cracks the code, the next question emerges. What do these whale symphonies feel like beneath the waves? Whale symphonies. Underwater, the hidden conversations beneath the waves. If you could slip beneath the surface of the ocean and drift quietly through the deep blue, you wouldn't find silence. Instead, you'd discover a concert already underway. Sound pulses all around you, long haunting melodies, sharp bursts of clicks, strange whoops and whistles echoing across the open sea, but all these aren't random noises. They're part of a complex communication system used by whales and dolphins, one that may be just as rich as any spoken language we know, and possibly even more so in ways we're only beginning to understand. Without a doubt, whales don't talk the way humans do. But in their own world, they've developed forms of vocal expression that go far beyond basic signals. Their societies rely on sound just the way ours rely on words. Humpback whales, for instance, are famous for their songs, which are long, structured performances that can last for hours, even an entire day. These songs aren't just noise, they are crafted with repeated patterns, rhymed sequences, and phrases that build into something bigger. Male humpbacks sing mostly during mating season, and while scientists believe the purpose is to attract females, no one knows exactly how it works. It gets even more fascinating though, because over time, these songs tend to evolve. A theme might drift through the Pacific one year, then fade away the next, replaced by a new version, almost like a hit song being remixed and passed along through the population. And all of it happens underwater, sometimes traveling dozens of miles across ocean currents. This idea of a cultural drift of melodies being shared, repeated, then changed suggests something deeper than instinct. It hints at creativity, and if whales are capable of creativity, even in this narrow musical sense, then what else are they capable of? Sperm whales, on the other hand, don't sing sweeping songs. Their language, as we have discussed earlier, is built around something called coders. They are short bursts of clicks that sound a lot like underwater Morse code, but these particular coders carry weight. They are used for more than navigation or echolocation. They are used socially. In one study, biologists in Dominica recorded a sperm whale named Rounder giving birth. As she labored, 11 members of her clan circled close, clicking in what seemed like coordinated pulses. The sounds weren't random, they were patterned and communal. It looked and sounded like support, an acoustic embrace from her family. This kind of moment doesn't happen in isolation, and it is part of a larger picture, one where sound ties individuals together across a lifetime. Sperm whales live in matrilineal groups, with each clan using its own unique set of coders, almost like an accent or dialect. These sounds are passed from mother to calf across generations, which means sperm whale culture isn't just about behavior, it's also about sound, and that sound is taught, not inherited. This is a big deal, because teaching requires memory, attention, and something very close to intention. A whale isn't born knowing its clan's coder, it has to learn it. Zoom out a little, and you'll find dolphins adding their own voices to the underwater chorus. Known for their intelligence and social nature, dolphins take vocal learning a step further, and in one Florida study, researchers found that a dolphin could mimic human vowel sounds, and not by accident. According to the study, the dolphin produced the sounds voluntarily, mimicking human vowels with surprising accuracy. For a marine mammal with no larynx and a completely different vocal structure, that was not just impressive, it's unexpected. It shows that dolphins aren't only skilled at making sounds, they're also capable of copying them, a rare ability shared by only a few species on Earth, like parrots and humans. And this imitation isn't just a clever trick, it's a glimpse into how animals might understand sound as a symbol. If a dolphin can learn to reproduce the shape of a human vowel, it may also recognize that certain sounds carry meaning, and possibly even assign meaning of its own. This is the kind of cognitive leap that moves beyond simple signals or reflexes. It brings us closer to something like true communication. With whales singing across oceans, sperm whales clicking in emotional sync, and dolphins mimicking vowels like little underwater linguists, it's natural to wonder, are we actually dealing with true language here? The answer, though, is complicated. On the surface, it certainly feels like language because these animals use sound in ways that are structured, flexible, socially learned, and often tied to specific situations. In human terms, that's how language behaves, but scientifically, the definition of language is much stricter. Human language isn't just about making sounds or repeating patterns. It depends on syntax, on rules for combining words, and on shared meanings that can be rearranged to express endless new ideas. So far, no animal species has fully met all those criteria. This is why researchers remain cautious. They're uncovering patterns that resemble grammar, repeated structures, meaningful timing, and sound systems that behave more like code than random noise. Still, they hesitate to say whales or dolphins use language the way we do, because it is not about questioning their intelligence. It is simply that we don't yet have a full translation, and until we do, there's a gap we can't claim to have crossed. With that being said, the gap is slowly shrinking as each new study brings us a little closer. Every AI model that spots a subtle shift in a whale's rhythm or reveals a dolphin's unique vocal signature chips away at what we thought we knew. We're starting to understand that sound in the ocean isn't just noise, it's identity, it's memory, and it might even be emotion. Maybe one day soon, we'll reach a point where the songs, coders, and whistles begin to feel less like mysteries and more like messages, ones we can finally answer or at least understand. Because beneath the waves, the concert never ends, and the better we listen, the more we might realize that the ocean's not as silent as we once thought. But what if those haunting melodies and rhythmic clicks aren't just sounds but syllables? As the symphony unfolds, scientists begin tracing the first outlines of a hidden alphabet beneath the waves. A phonetic alphabet of whale clicks, decoding the rhythms of the deep. In the middle of 2024, something unexpected surfaced from the depths. Not from the ocean, but from a research lab packed with data, algorithms, and years of patient listening. It was the kind of breakthrough that only becomes clear in hindsight, after thousands of hours of recordings and millions of lines of code. Scientists from MIT and their collaborators studying the Dominica sperm whale population announced they had uncovered what they described as a phonetic alphabet of whale clicks. This might sound poetic, but it was meant literally because for the first time, researchers had found structured, repeatable sound units in sperm whale communication that resembled the building blocks of language. The team had been working with data gathered by SETI, and their network of underwater microphones off the coast of Dominica had been recording non-stop, capturing every click, pause, and rhythm shared among a tight-knit sperm whale community. These were not captive animals or isolated calls. These were wild whales, living their lives, communicating in their natural environment, unaware that their conversations were being meticulously recorded. Once the data was collected, the real challenge began: sorting through it. Using advanced machine learning models, the team began organizing thousands of coders into categories, and what they found was stunning. In just one population, they identified over 157 distinct coder types. Each type was defined by the number of clicks, ranging from as few as 3 to as many as 40, and by the specific rhythm or spacing between those clicks. At first glance, it might seem like a whale simply clicks 4 or 5 times and then stops, but when researchers observed closely, they discovered something far more intricate. The tempo between each click wasn't random. The whales subtly stretched or compressed the timing in ways that changed the feel, or perhaps even the meaning of the message. It's kind of like how a human might say hello in different ways depending on their mood or who they're talking to. Sometimes fast and cheerful, other times slow and serious. It's the same word, but delivered differently. To explain these subtle variations, scientists turned to musical terms. When a whale changed the tempo within a single coda, either speeding up or slowing down, they called it rubato, a word musicians use to describe expressive shifts in timing. And when a whale added a tiny extra click at the end, almost like a flourish, they called it ornamentation. What made the discovery even more intriguing was how these elements worked together. Whales didn't follow rigid templates. Instead, they mixed and matched timing, tempo, and ornamentation to create new codas. It was as if they had a toolkit of sound syllables they could rearrange depending on the context. Some codas were quick and sharp, others were slow and drawn out. Some ended with extra clicks, while others didn't. The rhythm shifted based on who was nearby, what was happening, or even the emotional tone of the moment. One of the study's co-authors put it simply, "We're now starting to find the first building blocks of whale language." This was a bold claim, but it is far from empty. For years, scientists debated whether sperm whale codas were anything more than basic social signals or identity tags. Many once believed these click patterns were simple, even meaningless. After all, whales don't speak in words. They don't have lips or vocal cords, so it was easy to assume their sounds were primitive, but this research proved otherwise. Codas aren't random. They follow patterns. They repeat with precision, and they change with purpose. By identifying distinct coda types, each with its own rhythm and expressive variation, scientists took a major step towards showing that sperm whales may be using a structured system to communicate. It's easy to forget how little we truly know about whales. They live in a world hidden from view, communicating in frequencies we can barely detect, across vast distances we can hardly imagine. For centuries, they remained mysteries, giants of the deep, gliding through what seemed like silence, but it was never truly silent. We just weren't listening in the right way, but now, with better technology and a lot more patience, we're finally beginning to hear them. Slowly, carefully, we're starting to map the grammar of the sea, and maybe one day, if we keep listening, we won't just recognize the patterns. We'll understand the stories they're telling. So now we have to ask, if whales do have a language, one with structure, rhythm, even emotion, what does that say about their intelligence? What else might they know that we don't? And could they be telling stories, passing down knowledge across generations beneath the waves? Let us know your thoughts in the comments. And don't forget to like, subscribe, and share. If you enjoyed this video, click on the next video on your screen.